This video is going to be on section 2.3, so measures of the location of data. So we're going to start with quartiles and percentiles are common measures of location. Percentiles divide our ordered data into hundredths. So sometimes this gets confusing for people. So to score in the 90th percentile of an exam doesn't mean you got a 90 on the exam. It means that 90% of all the test scores are the same or less than what you got, and 10% of the test scores are the same or greater than your test score. Quartiles divide ordered data into fourths and are special percentiles. So the first quartile, Q1, is the same as the 25th percentile. So that means 25% of the data is at or below that value, 75% is above. The median, M, is the middle value of the data. So that's both Q2, the second quartile, and the 50th percentile. So 50% of the data is at or below that value, 50% is above. The third quartile, Q3, is the same as the 75th percentile. So 75% of your data is at or below that value, and 25% is above. So if we're going to do it by hand, you need to have the data ordered smallest to largest. I usually do this in Excel as well, just because I think it helps me to see where those values are and to see if they're reasonable. First, I find the median, and just know that it may or may not be one of your data values. If you have an odd number of data values, the median will be the middle data value. But if you have an even number of data values, the median will be the average of the two middle values. Once we find the median, we can find the first quartile. It's the middle value of the lower half of your data. And then the third quartile, it's the middle half of the upper half of your data. There's other ways to find it too, but sometimes when I have small data sets, I just find the median, and then I find the median of the first half, and then I find the median of the upper half too. Okay. So here's our first example. So I just want to remind you that you can follow along in the Excel sheet that's in Canvas. This has multiple tabs. We're on section 2.3, and this is our first example. Try it 2.13. So for the following 11 salaries, we're going to calculate the median and the quartiles. The salaries are in dollars. They are not ordered. That would be the first thing that I would say is put the data into Excel and sort it. We're going to find the middle value, that's the median. We're going to find the middle of the lower half for Q1, the middle of the upper half for Q3. And it's going to look a little bit like this, but we're going to do it together in Excel. I just wanted to show this to you because there's sort of, there's the way I said, like find the middle value, then find the next middle value. There's also these ways as well. And I call them sort of the n/2 and the n+1 method. So by hand. N here represents the number of data values that we have. So for our case, when I highlight down here, Excel tells me I have 11. I knew that. The first thing I'm going to do is actually I'm going to sort from low to high. Excel is giving me a little box that says, I didn't include the salaries in dollars piece. So it says, do you want to expand the selection? I'm just going to continue with what I have. And now it is low to high. And so by hand, I know I have 11 data values. So if I type 11 divided by 2, I get 5.5. So that's the middle of my data. I don't have a value like it's, you need a whole number because they're discrete counting values. So anyway, I'm going to round up. So when I get 5.5, what I'm really looking for is the sixth data value. So over here, this is my first data value, 2, 3, 4, 5, 6. So this 54,000 is the middle of my data. I have 5 values above it, and I have 5 values below it. 50% of my data is below 54,000, at or below, because see, I have two 54,000s, and 50% is above, at or above 54,000. The n+1 method is I'm looking here for the median. So that is the halfway mark. It's 50%, my 50th percentile. So I can also do 1/2 times n plus 1. So 11 plus 1 data values, that's 12. When I do this method, it rounds up, like that's just by adding that 1, that's what I get. I get a whole number, and I can see that it's my 6th data item. Okay, so that is different depending on if we have an odd number or an even number of data values, but I want you to know that, like, if you Google like how to find the median, you're going to see both of these ways out there. We're going to end up using Excel all the time, but I want you to just to know how to do this. So that is going to be 54,000. It's sorted here, not sorted, it's formatted here as general. If I want, I could make all of these numbers are going to be money numbers, accounting, currency numbers, but it might be automatically in Excel as just general. And then Q1, same thing, but now instead of having 11 values, I have 5. So if I use the divide by 2 method, I'm going to take 5 and divide by 2. I'm going to get 2.5. I'm going to round that up to 3. 1, 2, 3. So it's the 3rd value in my data set. That's Q1. So that's 40,500. 25% of my data is at or below that value. 75% is at or above. The n plus 1 method. So the fraction here, it's the first quartile. It's the 25th percentile. So that's equivalent to 1/4. You could do 0.25 as well. And then I'm going to multiply it by n plus 1. 11 plus 1 is 12. And I get the 3rd data value. So see here, 1, 2, 3, that's my 3rd data value. Q3, if I'm using sort of the n over 2 method, it wouldn't necessarily work to figure out the Q3, but I know I went 3 to get to Q1, so I'm going to go 3 to get to Q3, but starting at the median. 1, 2, 3. So this is the middle point of my upper half of my data, 69,000. So you can do the n plus 1 method, so you might like this method better. So 3rd quartile is the 75th percentile. So that's equivalent to 3/4. And then times 12, n plus 1. So that's the 9th data value. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So that is 69,000. So that's how we do it by hand. And if we go back here, you can see I have those in there so that you can look back at it. So 25% of the data is less than 40,500. 75% is greater. Half of the data is less than 54,000 and half is greater. And 75% of the data is less than 69,000 and 25% is greater. Now, that's a lot of work. So we want Excel to do the hard work for us. So we are going to use the Excel formulas. So there is the median formula for the median. There is the quartile formula that we can use for Q1 and Q3. So we use quartile.exe. We highlight our data and then we tell Excel which of the quartiles we're looking at, 1 or 3. We could use this for our median as well and just use the number 2 because, again, the median is the 2nd quartile. A couple of things to note. Your version of Excel might not have the .exe. It might just have quartile as a formula. That's fine. If you have the updated version, you might also have the .inc version of the quartile formula, and that just calculates these values a little bit differently than the .exe. I'm going to use .exe, so if you use that, then our numbers will match. But just know that there's different ones out there. Actually, so we're going to go back to Excel and calculate those values with Excel. So here's my median formula. Highlight my data. And yeah, it sort of did that a little bit weird because I double clicked in the wrong space. So I'm going to go down to A13. Normally you would just highlight it and it would work out better. Then we're going to do the quartile.exe. So you see here, there's the 3 available. This one down here with the little warning sign is an older version, but it might just be available to you if you're using the online Excel. So I'm going to use the .exe. I'm going to highlight my data, and then I'm going to tell it I'm looking here for Q1. You see, we're getting the same numbers that we did by hand. And then I'm going to do the quartile formula.exe, highlight my data, and just know that if you sort of forget to put in which quartile, Excel will remind you. And if that's the case, then just put in which quartile you're looking for and you'll be all set. All right, so the next thing we're going to talk about is the interquartile range. The IQR is a number that indicates the spread of the middle half or the middle 50% of the data. Sometimes we're just interested in how spread out all of our data is. So we would find the range, which is the largest value minus the smallest value. But then outliers might be involved. And so we might get a wider spread or wider range than is really indicative of how our data looks. So we'll often look at the IQR because it indicates the spread of the middle half or the middle 50% of our data. We calculate it by taking Q3 minus Q1. We should always have a positive number for the IQR. So if you get a negative number, you probably did Q1 minus Q3. Just switch them around. And we can use this to help determine potential outliers. The method we use is the 1.5 method. And so if we take 1.5 and we multiply the IQR by that, we can subtract it from Q1 and look for numbers less than that. And we can add it to Q3 and look for numbers bigger than that. Those numbers could be potential outliers, and we just want to take a look at them to make sure we didn't make an error when we collected the data, reported the data, or maybe it is good data and we're just curious about why that value is so different. So if we go back to our example in Excel, we can calculate the IQR. So again, this is Q3 minus Q1. See, I got a positive number there. If I had done it, Q1 minus Q3 would be negative. And then I'm going to do 1.5 times my IQR. I'm using cell references here. So I get 42,750. Oh, sorry, let's go back to IQR. So 50% of my data is within $28,500 of each other. So I have my 1.5 times the IQR here. And now my lower values that I'm going to look to see if there's any numbers less than this number is Q1 minus that 1.5 times the IQR value. The parentheses here, because I formatted it as currency, that just means it's a negative number. These salaries are all positive, so I don't have any numbers that are potential outliers on the low end. And then Q3 plus that 1.5 times the IQR is 111,750. I do have one salary bigger than that, and so that would be something that I want to take a look at to see if I recorded it correctly, if it was reported correctly, or maybe it's just, you know, a higher salary, and I might be interested in finding out which one that is. All right. So I'm going the wrong way here. So there's the IQR, and that's what we just calculated. So we're going to do another example. This one has a different number of data values. These are test scores from the first exam in a first-year math class. They are also not sorted. So when we go over to Excel, we're going to look down here. And the first thing we're going to do is we're going to sort them. I'm going to actually use the test scores here because it keeps telling me that I need to expand my selection. See, it still isn't here. There's still more information, so it still wants you, still ask you that question. But it did know that test scores was the title, so that didn't mess it up. All right, now we have our test scores ordered. I have the by hand column, and now for this example, I have a .exe and a .inc column. So I'm just going to put in the n over 2 here and the n plus 1 just to keep them sorted in my head or straight in my head. And this time, when I highlight all the data, Excel is telling me there's 20 of them. So it's an even number of data values here. So it's going to be a little bit different, okay? So I have 20 values. So 20 divided by 2 is 10. So let's go look and see what happens at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we have 20 values. So 10, there's 10 in the first half and 10 in the second half. So this is a situation where we don't have a data value that's on that marker, and I can't round up because it's a whole number. So what I'm going to do here is I'm going to take this value here at 10, my 10th spot, and my 11th spot. I'm going to highlight these guys. I'm going to average those out, and that's going to be my median. So here I can do this in two ways. I can use the average formula and say, average these two numbers, please, and get 80.5. Or I could do, instead of the average formula here, I'm just going to do it over here. Another way would be to do 80 plus 81. I could type these numbers in and divide by 2, right? You're going to get the same thing. So either way would work. With the n plus 1 method, I'm looking for the median here. So 21. See, this is where we get the decimal in this case. So now this is telling you at 10.5 is where your median is, but there's no value there, right? So you need to take the 10th and the 11th values and average them together. So I just wanted to show you how this works just so that you can decide which one works better for you, or we'll just use Excel. If you continue to do by hand, right? So now we have, now we're going to use that 80, even though we used it in the calculation before, because it's not our median. So we have 10 values here, okay? So if I divide 10 values by 2, I get 5. So again, 1, 2, 3, 4, 5, 6. I'm going to take these two and I'm going to average them together. And so I'll have 5 values below that number, and I will have 5 values above that number. So by hand, you know, maybe it's a little more confusing, or maybe you've done this before and it makes total sense. Okay, 72.5. So again, when I use the n over 2 method, I'm kind of just doing some counting. So from here, I'm going to go 1, 2, 3, 4, 5. So that's my 5th and 6th value to get Q3. So these are the first 5 in the second half, and these are the second 5 in the second half. So I'm going to average these ones together to get my 3rd quartile, my Q3. So what did I do here? I didn't let it type out the whole command name. That's what happened there. Okay, so now let's see what happens with Excel with the .exe and then with the .inc. So I have my quartile.exe formula. I'm going to highlight my data, and I'm looking for Q1. It's a little bit different than by hand. And that's, again, because Excel is sort of deciding like how far away the median really is, and how much weight, and all these different pieces of data are more weighted this way or that. It's using a more complicated calculation than we do by hand. None of them are wrong. None of them are super right either. You just have to be transparent about which one you're using and go forward from there. So for the .inc, we haven't used this one yet. I'm going to use, I'm still going to highlight the same data, and I'm going to do the first quartile, but I use the INC formula, and you can see it's a little bit different too. This can be confusing. You're like, what does this all mean? And you can Google it and you can look into it. I don't think that the explanation adds a whole lot to the understanding of the fact that 50% of the data is at or below these values. None of these are actual data values. So in Stats 1, does it matter which one? Actually, these were way lower now that I'm looking at, because I did Q1. I apologize. So I am going to, I was like, wait a minute, those are wildly different. So I'm going to actually cut this and put it in here. And I am going to cut this and put it in here. All right, now it looks a little bit better because they were off. I was like, they're wildly different. All right, makes more sense. I don't have to do the .exe and the .inc for the median because there's just one median formula. Okay, so this is the median formula. And I get the same value. That makes sense. So now here it's, I'm sorry, in Q1 and Q3 in the quartiles where we're going to see those differences. And again, when we look at the first half of this data, the .exe and the .inc aren't, they're just using different formulas. But if you look and you look at how we did it by hand, there is no 70.75 or 72.5 or 74. And half of that first half is below all three of those numbers. So for our purposes, that's perfectly acceptable. Okay. All right, let's try this again. So we're going to do quartile.exe first. I'm going to use comma 3 this time because I'm looking for the third quartile. And again, I get something a little bit different than what I got by hand. And then I'm going to use the .inc here. And I'm going to do comma 3. And this one is also different. So we do have a 90, right? But we don't have any of these values. So for our purposes, they're all sufficient. Okay. I'm sorry about confusing you up here with the median. All right. So if you are scrolling through the slides with me, when the first time I made these, we're going to do the IQR now. I made a little bit of a mistake down here. Maybe you're getting used to me and my mistakes. So what is our IQR? So you have to decide which one of these formulas we're using. I would like to use the .exe. So I am going to do my IQR with the .exe. So Q3 minus Q1, that gives me an interquartile range of 20. So the middle 50% of my data has a range of 20 units. These are test scores. To find possible outliers, I'm going to take 1.5 and multiply it by 20. That gives me the number 30. And then I'm going to take Q1 and I'm going to subtract that 30. So I'm going to look at my scores and say, do I have anything, did anybody score lower than 40.75? My lowest score is a 65, so I don't have any outliers on the low end. On the high end, 90.75 plus my 1.5 times the IQR gives me a score of 120.75. The highest I got was 99, so I don't have any outliers on the high end either. So back to the slide, I messed up here when I made this example the first time. I used 20, so I did 90.75 plus 20 and used the wrong number. So make sure you use the 1.5 times the RQR when you're looking for your outliers. So percentiles, we can calculate percentiles by hand. Data has to be ordered smallest to largest. This is the formula we would use if we were going to do it by hand. K is the percentile you're looking for, 30 percentile, 30th percentile, 70 for 70th percentile. N is the total number of data values you have. So this is like the n plus 1 method, only for percentiles. And I is the index, which is the ranking or position of the data. So the I is like the location in your ordered list where that value is going to be. So just like we did for our quartiles, If I is an integer, then the kth percentile is the data value in that position. If it's not, you're going to round up and down. So you're going to look above and below that number, and you're going to average those two numbers to get your data, the position that your data value will be in. Now, maybe you have a data value, but you want to know what the percentile is for that data value. So then you're going to use this formula. Here, X is the number of data values counting from the bottom of the list up to, but not including the data value for which you want to find the percentile. Y in this formula here is the number of data values equal to the data value for which you want to find the percentile. And then again is the total number of data values. Then you get a decimal there, so you multiply it by 100 to get the percentile. And then you're going to round to the nearest whole number. So our example for this, we have 30 ages for Academy Award-winning Best Actors in order from smallest to largest. So in this case, it's already ordered for us. 18 is the youngest, 77 is the oldest. And we are going to find the 70th percentile and the percentile for this data value here, the age of 47. Okay, so over here, if we scroll down, so by hand, we have to go back and we have to look at our formula. Or I'll go forward and show you the steps. So we need to know K, so that's the percentile we're looking for. We need to know N, how many data values we have. And then I is going to be that index. So here is our formula. And if you go back a couple of slides, you can see it how I originally gave it to you if you prefer the way that that looks. So the way you would do this in Excel is you would say equals, and I like parentheses so that it does the order of operations correctly, the 70th percentile times 30 plus 1. You could just type 31 if you want. So actually, I'm going to put that over here, just like I did before. So that's the position that I'm looking for, okay? So it's not, I'm an integer. So I'm going to find the 21st and the 22nd data values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So these two values here are the two I'm going to average to get my data value that is at the 70th percentile. So they are 62 and 64. So I can do 62 plus 64. I'm sure you know that those are going to average to 63. So that is the 70th percentile. 70% of these best actors were no older than 63. They were younger than 63. 30% were older than 63. So that's how you find the percentile. When you know the percentile, that's how you find the data value in that spot, in that location. But then if we are curious about what the percentile is for this data value 47, we have to use the other formula. So there are 15 values below 47. So if I go over here and I'm just going to let Excel do the counting for me. So down here it says there's 15. Okay, so 15 values below 47. When I look at my list, there's only one value of 47. And again, I have 30 values. So this is a little more complicated formula. If you remember, and again, you can go back to that other slide. This one you can just do in the cell. You can do wherever you want. But we have that 15 data points before 47, then plus 0.5 times how many 47s we have, 1. And then we divide that by the number of data values we have, which is 30. And then we multiply, I'm going to add an extra parentheses in here. We multiply that whole thing by 100 to get a percent number. So 51.67. So if you remember, what we said is we're going to round that up. Okay. I want to show you here when we're on the home menu. So just remember, right? 0 to 4 rounds down, 5 and up rounds up. But if I just decrease my decimal places, Excel is going to do the rounding for me. There's other ways we'll look at rounding later in the course, but that's just one way you can do it. So that's the 52nd percentile. So 52% of values of ages are at or below 47, which would make 48% at or above 47. So a lot of work, both of those. So if we want to use the Excel formulas, we have the percentile.exe formula, so very similar to the quartile formula, but this time we put in the percentile that we want instead of the quartile. And you can do this as a decimal, or you can put the percent symbol in, and I'll show you both of those in a second. And then if we want to find the percentile for a specific value, we use percentrank.exe. And then you highlight your data, you tell it which value you're looking at, and then this is significant digits. And I think it gives you 3 if you don't tell it a different number. So it's going to give you 3 decimal places, and then you would, bump that 2 to the right to look like the traditional percent we're used to. Okay. So it might be left blank. And again, these are going to give us a little bit of a different value than if we do them by hand. So let's go in here and do these. So this is percentile.exe. You can see there were a lot of options there. I'm highlighting all my data and putting in a comma. Now I'm looking for the 70th percentile. So you can do 0.70 and, parentheses and hit enter, or you can do 70%. Either one, I believe Excel understands, but it doesn't just understand 70. Okay. So I get 63.4. So it's a little bit different than what I got by hand. So again, that's not one of our data values, but 70% of our data is below 63.4. The percentile for 47, so we're going to use percent rank this time. So this returns the rank of a value. I'm going to highlight my data, put a comma in. I'm going to tell it I'm looking at 47. And then I don't need to put in the number of digits. So I wonder if I need the comma. I don't. So again, this does it as a decimal. And you can see if I move these decimals back out, those are essentially the same. I mean, it's off by a little bit, but you would round this up to 52. This rounds up to 52. And so the percentile for 47 is 52. Okay. Again, the Excel formulas are really straightforward and much faster than doing them by hand. So interpreting percentiles, quartiles, and the median, a percentile indicates the relative standing of a data value when the data are sorted. 15% of data values are less than or equal to the 15th percentile. A percentile may or may not correspond to a value judgment about whether it is good or bad. It's just a location. So one example, on a timed math test, the first quartile for time it took to finish the exam was 35 minutes. So that means that 25% of the students finished the exam in 35 minutes or less. 75% of students finished the exam in 35 minutes or more. So a low percentile could be considered good, as finishing more quickly on a timed exam is desirable, because if you take too long, you might not be able to finish. But maybe it's, a half-hour class, right? And so it depends on your perspective and the situation when you're talking about percentiles and quartiles. This is a similar example at a community college. It was found that the 30th percentile of credit units that students are enrolled in is 7 units. And so what does this mean in this context? It means that 30% of students are enrolled in 7 or fewer credits. 70% of students are enrolled in 7 or more credits. There's no good or bad value judgment associated with a higher or lower percentile. We all attend community college for different reasons and we have different needs, and our course load is going to vary according to that. So that was section 2.3 for Stats 1.